Can I ask you guys? Stop talking, please. All right. Do you guys have questions on stuff before we get started? Valentina.
Could you do one of those from like 9 through 12?
Sure. Do you have one in particular you're eyeballing?
Like an hour, maybe like 11 or something.
Okay.
You have so many.
All right. Stop talking. So, come on. So Valentine asked about 11. So we're going to be using the graph up here to do this. For me to figure out which part of the graph I need to look at, I'm going to look at where the x is approaching. X being positive infinity is talking about like this end of the graph, so I'm looking at that part. The y value that is approaching appears to be 2. So I just write x, or the f limit as x approaches positive infinity of f(x) equals 2. So I use the bottom part to figure out where on the graph I'm looking, and then I just basically write down the y value for that part of the graph. Yeah. Sure. So again, I go for this part. So that's the right side of 1. So we're talking about that part of the graph. Because that's pointing down, the y is like negative infinity. Okay? Yep. And that's it. That's like all there is to it. It's just describing, like all these limits are describing like what the arrows on the graph are doing. So the x part talks about where on the graph you're looking, and the y part talks about like where's the arrow pointing, up, down, or to a specific value. Everybody feel okay there? Other questions? Nobody? That's it? Okie dokie. Well, then it's homework quiz time. Like a half an hour or 40 minutes worth of stuff to talk about for today. So if you guys would lend me your attentions for that amount of time, that would be great. So in 14.3, what we're going to be talking about is solving inequalities. So, something like this, like x squared minus 4 is greater than 0. How many solutions are there going to be to this inequality? More than 2. How many values for x are going to satisfy this inequality? Already more than 2. More than 4. Infinitely many is correct. Yeah. Does that mean that any number is going to be a satisfactory answer? No, but there are infinitely many satisfactory answers. So what we're going to be looking to do is to find a way to describe those infinitely many solutions. The way we're going to do that is using an interval notation. So our plan for how to do this will outline as follows. So I'm going to call there a step 0, which is just get everything onto one side. I'm going to call that step 0 because for the most part, when you have an inequality to solve, it's usually already got 0 on one side, and there's nothing really to do there for that very first step. So step 1 is going to be to find all the zeros and discontinuities. Now, if we look at x squared minus 4, that's a polynomial function, right? Polynomials have no discontinuity, so all we're really finding on that one is a 0. But if you had a rational function, those can have zeros and discontinuities, so we'd have to make sure to find both of those for like a rational function. Everybody's okay there? Once we've found those, so we're going to label a number line with the answers that we get from number 1. So we're going to use either closed circles or open circles to label those zeros and inequalities. Open circles we'll always use for discontinuities. Closed circles or zeros could be closed or they could be open. It's going to depend on the type of inequality we have. So in this case, because it's a strict greater than inequality, it's going to be an open, right? So again, we'll always use open circles for discontinuities. And then maybe we'll use an open for a 0, or maybe we'll use a closed for a 0. That decision depends on the type of inequality, right? So that's maybe, okay? So the zeros are maybe, it just depends on the type of inequality we have. Okay, we don't know from the get-go until we look at the inequality whether we're going to be drawing it with a closed circle or open circle. Discontinuity is always open. Everybody's okay? Now it's easy to tell for the 0 whether I want to use open or closed. All I have to do is look at the inequality symbol, but I got to check it. Step 3, I'm going to pick a test value. So then we're going to pick a test value for each region separated by our answers from 1. After we've decided on our test values, we'll plug those test values in to determine if the result is either positive or negative. And our last step is look at the results from the previous step, which was 4, to determine which regions satisfy the inequality. And then we'll write those intervals. So this is basically my plan. Now, this feels like a lot of writing in practice. It's really quick and it's relatively easy. This first time through, I'm going to write out in a lot of detail what I'm doing each step. And after that, we'll just kind of compress the work a little bit so it's a little bit more manageable and requires a lot less writing. But I just want the first time through for you to kind of see where I'm doing each step and what it looks like moving from, step 1 to 2, from 2 to 3 to 3 to 4, etc. Okay? All right. So if I look at my original problem here, everything's on one side, so step 0 is done, right? There's really nothing to do there. Step 1, it's a polynomial, so there's no discontinuities. To find the zeros, we're just going to take the polynomial and set it equal to 0 and solve. X squared minus 4, maybe I factor that. So when I solve it, I get the solutions 2 and negative 2. So on step 2, I'm going to draw a number line. I'm going to label it with my zeros and discontinuities. Now, I know because we have a strict greater than, I'm going to be using open circles for my zeros, right? So I'm going to do an open circle and an open circle. In step 3 now, I'm going to pick a test value. So I need to pick a test value that's less than negative 2. Maybe I'll pick negative 3. Pick a test value between negative 2 and 2. Maybe I pick 0. And then pick a test value greater than 2. Maybe I'll pick 3. Does it matter the test value that I pick? No, it just needs to be in that region somewhere in between the values. Pick numbers that are easy to evaluate, though, they're easy to work with. You have the choice. Don't pick something kooky I'm going to pick 17/31. That's a terrible choice. Don't do that. Make your life easy, right? So on part 4 now, I'm going to, oops, there's still open circles there. I'm now going to plug this in. So negative 3 squared minus 4. That's going to give me a positive value, right? Negative 3 squared is 9. 9 minus 4, that's positive. I don't care what the number exactly is. I just care about the sign of it. If I plug 0 in, I get 0 squared minus 4. Well, that's a negative value. Go ahead. If I plug positive 3 in, that's going to again be 9 minus 4. That's a positive value. Everybody okay with what I did with those test values? So then on step 5, what I'm going to go and do is I'm going to look at what I have here. I need greater than 0. So if I go and I look, which regions correspond to greater than 0? The positive ones. So those will be my regions that I want. So if I look at that first region, that includes the left-hand arrow, so that goes to negative infinity, or starts at negative infinity, and goes all the way up to negative 2. And because I have an open circle at negative 2, I'll use a parenthesis. I'll do my U. My second region starts at 2 and includes the right-hand arrow, so goes to positive infinity. Since I have an open circle at positive 2, I'll use a parenthesis. And then another parenthesis at 0. So this is going to be my final answer. Does that feel okay? Now in the next ones, instead of like redrawing the number line every time, I'm just going to draw it once and just kind of keep adding stuff into it. So it's 1, but I think the first time through, seeing sequentially like what I'm doing on each step, I think is helpful. All right, let's grab our next example. Yes. I don't know.
I was supposed to go to test questions in our class.
You can go when we're done. All right. So here's our next example. So first step would be to get everything on one side. Well, that's done already, right? I notice that this is a polynomial equation, so there are no discontinuities. So all I need to do is worry about finding the zeros. So to solve this polynomial, I'm going to start by factoring out a greatest common factor of x. And then the resulting x squared minus 4x plus 4, I notice can factor. The two numbers that multiply to give me 4 and add to give me negative 4 are negative 2 and negative 2. So I have the solution 0, 2, and then 2 again. Everybody feel good there? So I'll draw my number line. So I'll label it with 0 and 2. Because it's a or equal to inequality, I'm going to use a closed circle for my zeros. Everybody feel good there? I'll pick some test values. So I'll pick maybe negative 1, positive 1, and then 3. And now to evaluate this, I'm going to do this in a sneaky way so I don't have to, I can just use mental math to do this. So if I plug negative 1 in here, I'm going to have negative times negative times negative. Everybody agree with that? So negative times negative times negative is negative. Everybody agree? If I plug positive 1 in, I'll have a positive times a negative times a negative. So that's going to be positive. If I plug 3 in, it'll be positive, positive, positive. If I multiply 3 positives, I get positive. Is everybody okay with how I did that? I like to look at the factored form usually when I'm doing the tests because it just makes the arithmetic really simple. I can do it without a calculator. I don't have to plug anything in and waste a bunch of time doing computations. I can add and subtract whole numbers in my head and just decide if they're positive or negative result. I don't even have to find the number. I just have to know if it's positive or negative. It's a real low bar to clear. I'm real happy with that method. Now, because we're looking at less than or equal to 0, I'm interested in this region. Everybody agree? And what else? And 2. Because it's less than or equal to 0, right? So from the first region, that'll go from negative infinity to 0. And because 0 is closed, I'll use a bracket. And then I also have just that number 2. So I'll just use a set bracket around the 2. So my answer could be something less than or equal to 0 or the number 2. Any of those x's will satisfy that inequality. It's easy to miss the 2. Easy to miss that. Be on the watch. Let's go and do another example. I think I got 2 more. Okay. So again, step 0, that's taken care of. So I just need to find my zeros or my x-intercepts. So I set the numerator equal to 0. And then I need my discontinuity. Since it's a rational function, I know that those can exist. So I set the denominator equal to 0. Everybody feel good there? Draw my number line. So the -1, that's a discontinuity. That always gets an open circle. The x equals 4 is at 0. That's going to match up with the type of inequality I have, which is an or equal to. So that gets a closed circle. Everybody good with the decisions we've made so far? Now we'll pick some test values. Let's do -2, 0, and 5. Everybody's okay there? When I plug -2 into the numerator, I have a negative minus 4. Well, that's going to give me a negative. When I plug -2 into the denominator, -2 plus 1. Well, that's going to be a negative. Negative over negative is positive. When I plug the 0 in, 0 minus 4, well, that's negative. 0 plus 1, well, that's positive. Negative over positive is negative. When I plug 5 in, 5 minus 4 is positive. 5 plus 1 is positive. Positive over positive is positive. Everybody good with how I did that? Nice and easy, real simple, quick. You could plug the things in and get the actual number if you want. I don't think it's worth it. To me, I'm just going to do it the way I've been doing it because it's so fast and simple. All right, since it's greater than 0 or greater than or equal to 0, I'm looking for the positive parts. So that first interval is negative infinity up to -1. Because it's an open circle, I'll use a parenthesis. The second interval is from 4 to positive infinity. Because it's a closed circle at 4, I'm going to use a bracket. And there's my answer. What do you guys think? So far, so good? How's this feeling? I think this is usually pretty easy if you approach it in this way. One more example, and then I am done for today. How's that sound? Muy bueno, I hope, right? All right, let's look at this one. Oh no, look at this thing. Yeah. What about this do we not like? The square root and also The absolute value, right? Both of those things can make some complication for us. It's still like a rational thing, right, though? So to find the x-intercept, we'll take the numerator and set that equal to 0. Well, to solve for that, we'll square both sides. That'll cancel the square root. And we'll just subtract the 4 over. Everybody good there? Okay. For the discontinuity, that's going to be the denominator equal to 0. Now, who remembers how to solve an absolute value equation? You have to split it into two things, right? So the x minus 1 could give us the positive result, or the x minus 1 could give us the negative result. But here's the nice part. Positive 0 and negative 0, still just 0, right? So these two solutions really collapse down into just 1. So we just get x equals 1. Everybody okay there? But there's one other thing that can cause a discontinuity here. The square root, right? Can I square root every number? No. What numbers can't I square root? Negatives. You can take the square root of 13, it's just a decimal, right? But negatives give us what kind of result? Imaginary, yeah. So I know that then x plus 4 has to be greater than or equal to 0, right? There's the stuff underneath the radical. Can't be negative. Which implies that I have a discontinuity for everything else, i.e. x is less than negative 4. So let's go ahead and draw our number line. Now, because this is a strict inequality, I know I'm just going to be using open circles for both my zeros and my discontinuities. Because x can't be less than negative 4, I don't even need to pick a test value from that region. Just, there are no answers in there, period. No bother, no reason to test it. If I did pick a test value in there and tried plugging it in, I'm going to get an imaginary result. Your calculator is going to say error, non-real. So don't worry about that. So I just need to pick the two test values. All right, so if I plug 0 in, 0 plus 4 is positive, and the square root of a positive is positive. If I plug 0 into the denominator, well, the absolute value of anything is positive, right? So it doesn't even matter. I don't have to think about it. The bottom is just always going to be positive. So positive over positive is positive. Everybody feel good there? If I plug a 2 into the numerator, x plus 2 is positive. The square root of a positive is positive. The denominator, always positive, because it's an absolute value. Positive over positive is positive. So my answer is going to be these two regions. So negative 4, and I'm going to use a parenthesis because there's an open circle at the negative 4. To 1, I'll use a parenthesis at 1 because there's an open circle at 1. And then we'll go 1 to positive infinity. Again, there was an open circle at 1, so that gets a parenthesis. And I'm done. What do you guys think there? Shouldn't be too bad. For your homeworks, I'm going to ask you guys to do 35 to 36. I'm sorry, to 38. I don't want you to do 39 or 40. You guys can do 41 to 47. I don't want you to do 48, but then you can do 49 to 56. I just skipped the ones where you'd have to do like the polynomial division stuff to solve the polynomial. We just did that. I don't need you to do it again. It's just time consuming. You get the idea without having to do that. And guess what? That's it for today. That's it, in fact, for chapter 14. So, excuse me, can I just finish and say a couple of things here? So that finishes up chapter 14. So that test will be coming here beginning of next week. Yep.
Next week?
Friday.
Wait, next week Friday? No, this week Friday we're gonna review.
You asked me if we're going to review. I said Friday. Yeah.
Okay. Oh, but Tuesdays when we have the concert and stuff.
Well, then we'll figure it out. We'll figure it out.
Oh, it's not that much, I feel like.
No, this is a short test also. Yes. Yes, agreed. So seniors are all going to take the chapter 14 test. Next is chapter 15. Seniors, you guys will be responsible for that material. That'll probably be the last topic that you'll be responsible for. Depending on when that test date hits, you may or may not have to take the chapter 15 test, but it would appear on your final exam. Okay? If you would need to take one. Juniors, we're going to do chapter 15. We're going to take a chapter 15 test, and then we have one more set of topics after that we'll do after the seniors leave, dealing with like sequences and series. And that should close out our year.
Wait, but I was going to Nebraska.
It's like the day after the last day of school.
Okay.
It's like right there the same week you finish, the senior exams are like the next day or two or something.
Okay. I have to do my AP Gov. My sister's graduating college, so I have to do my AP Gov in Nebraska.
I would talk to counseling. They're the one that do the exam schedule changes. Yeah, Emmy? Sure.